Hey guys, today we're going to be looking at graphing exponential functions. So we're going to start off by completing a table to help us graph y equals 2 to the x. This table on the screen is a little tiny for me, so I'm just going to write the table out over here on the side. For 2 to the negative 2, remember that if I have a number to a negative variable, so say x to the negative b, that's the same thing as 1 over x to the positive b. So that means that I can rewrite 2 to the negative 2 as 1 over 2 to the positive 2, which is 1 over 4. So this guy right here is 1 over 4. For 2 to the negative 1, same idea. I can write that as 1 over 2 to the positive 1, so that's just a half. 2 to the 0 is just 1. 2 to the 1 is 2, 2 to the 2 is 4, and 2 to the 3 is 8. So there's my table of values. If I plot that on my graph over here, I have negative 2 a fourth, so that's going to be pretty close to 0. Negative 1 a half, that's going to be in the middle. 0, 1, 1, 2, 2, 4, 1, 2, 3, 4, and 3, 8. So 4, 5, 6, 7, 8. There we go. And then if I connect that. So this is an example of exponential growth. We call this exponential growth because this function is growing as x approaches infinity. So as x approaches infinity, y is also approaching infinity. And as x is approaching negative infinity, y is actually approaching 0. As these values keep getting more and more negative, negative 3, negative 4, negative 5, you're just going to get numbers that are very, very close to 0, but you'll never actually get 0. The y-intercept for this graph is 0, 1. The x-intercept, there is none, right? If those numbers are just getting closer and closer to 0, I can never put any number in for this exponent that's going to make this y value 0. So there's no x-intercept. That means that the x-axis is an asymptote. The equation of that asymptote is y equals 0. The domain of this function is all real numbers, so I can plug in any number for x and get out a value for y. The range, however, is 0 to infinity. Parentheses around both of those. I'm not going to include the 0 because, again, I can never get to 0. There's no number I can plug in for x and get out a 0 for y. And then I go to infinity, and I know that I can never include infinity, so that's a parenthesis as well. In general, if b is greater than 1 in this kind of equation, y equals b to the x, if b is greater than 1, then the function is increasing. So this function is always going to be increasing. Let's look at number 2. Complete the table and graph y equals 1/2 to the x. So I'm going to do the same thing. I'm going to do a little bit of work for my table over here, and then I'll fill in those values as I go. So I need x, y. For negative 2, I would have 1/2 to the negative 2. Again, with this negative exponent, what I can do now is flip this fraction to make that exponent positive. So I would have 2 to the positive 2, right? Because 1 over 2 becomes 2 over 1, so that's 4. So I have negative 2, 4 as 1 point. For negative 1, I have 1/2 to the negative 1. That's the same thing as 2 to the positive 1, so that's 2. For 0, 1/2 to the 0 is 1. 1/2 to the 1 is just a half. And then if I have 2, that would be a half squared, which gives me a fourth. And then for 3, 1/2 cubed gives me an eighth. So I have a fourth and an eighth. So if I plot that, negative 2, 4, negative 1, 2, 0, 1, 1 1/4, 2 1/8. So this guy is going to look like this. This example is an example of exponential decay. We say this is exponential decay because this function is decreasing as x approaches positive infinity. So as x approaches infinity, y is approaching 0. And as x approaches negative infinity, y approaches positive infinity. The y-intercept of this graph is 0, 1. There again is no x-intercept. Again, there's no value that I can plug in for x and get this y value out to be 0, which means the equation of the asymptote is the x-axis, which is y equals 0. The domain of this function is all reals, and the range is from 0 to infinity. In general, if 0 is less than b is less than 1, then the function is decreasing. Okay, let's do a couple of practice problems. We're really going to be looking at what kind of transformations are occurring in each of these examples. I'm first going to set up a table for number 1 for f of x is 3 to the x and g of x equals 3 to the negative x. For 3 to the negative 2, that's the same thing as 1 over 3 squared, so that's 1/9. 3 to the negative 1 is the same thing as 1 over 3. 3 to the 0 is 1. 3 to the 1 is 3. And 3 squared is 9. There's my table of values for 3 to the x. I'm going to go ahead and graph that. So at negative 2, I'm at a 9th. It's going to be really hard to get in here. Negative 1 should be a little bit higher than that. 0, 1, and 3, 9. So if I connect this, it's not beautiful on here, but we get the idea. There's 3 to the x. I'm going to do 3 to the negative x in a different color. So for 3 to the negative x, if I have 3 to the negative x and x is negative 2, that's 3 to the negative times a negative, so 3 squared, that gives me 9. For 3 to the negative x, where x is negative 1, I have 3 to the negative 1. So that's 3 to the positive 1, which is 3. 3 to the negative 0 is the same thing as 3 to the 0. That's 1. 3 to the negative 1 is going to be a third. And 3 to the negative 2 is going to be 1/9. So now if I graph that set of values, at negative 2, I'm at 9. Which is somewhere up there. It's very hard to see on here. I apologize. On negative 1, I'm at 3. 0, I'm at 1. And then my function just continues to decrease and approach 0. So again, this turquoise looking color is 3 to the negative x. And this red over here is 3 to the positive x. So when I'm trying to figure out what transformation occurred here from f of x to g of x, I can see that this function just flipped over the y-axis. The math word that we use for flip is reflect, right? So this function was reflected over the y-axis. For part B, the point of intersection of these two graphs is that y-intercept at 0, 1. The end behavior of f of x. So for f of x, that red function, as x approaches infinity, so the red, as x approaches infinity, y is also approaching infinity. And as x approaches negative infinity, y approaches 0. For the end behavior on g of x, I can see that as x approaches infinity, y is approaching 0. And as x approaches negative infinity, y is approaching infinity. Number 2. This one's a little bit different from number 1 in where the negative is. So in number 1, we had 3 to the x and 3 to the negative x. So the x was being negated. In number 2, I have e to the x and negative e to the x. So in this case, the entire function is being negated. So let's see what happens here. Again, we're going to start with that table of values. There's my table. Here we go. So for e to the x, if I have e to the negative 2, that's going to be 1 over e squared. For e to the negative 1, that's going to be 1 over e to the first power. E to the 0 is 1. E to the 1 is e. And e squared I can just leave as e squared. I just know that that's bigger than e. So when I plot this thing, I know that my y-intercept is at 0, 1. And it's just going to follow the same shape as the other graphs. I'm just going to sketch this one because these are all irrational numbers. So I'm not exactly positive where to plot these anyway. I could obviously figure that out. I know that e is like 2 and change, but I'm not going to go crazy. This is just a sketch. For e to the negative x. Oops, and this is wrong. This should be negative e to the x, right, guys? Let's go back and fix that. So when I fill in that table of values, I'm really just negating all of these values. So it's going to be negative 1 over e squared, negative 1 over e, negative 1, negative e, and negative e squared. So when I plot this one, I know that my y-intercept is 0, -1. And just to check here, for 1, I'm going to be at negative e, so that's about 2 and change. And then for -1, I know that that's where it's going to start getting closer to 0. So now if I fill in that shape, that graph should look something like this. What transformation occurred from f of x, the red, to g of x, that turquoise color? I can see that this flipped over the x-axis, so this is a reflection over the x-axis. What is the point of intersection of these two graphs? There is none, right? This function is going to approach 0 but never cross, and this function is also going to approach 0 but never cross. So these two functions are never going to intersect. For my end behavior of f of x, as x approaches infinity, y is also approaching infinity, and as x approaches -infinity, y is approaching 0. For my end behavior on g of x, as x approaches infinity, y is approaching -infinity, right? Because this thing is shooting down. And then as x approaches -infinity, y is approaching 0. Number 3, I'm going to do this in the same way I did my other two. I'm going to set up a table of values first. Okay, for 1/2 to the -1, that's going to be the same thing as 2 to the +1, so that's 2. 1/2 to the 0 is 1. 1/2 to the 1 is 1/2, and 1/2 squared is 1/4. So if I graph that, I know I have the point -1, 2, 0, 1, and then I'm going to start approaching 0. And I know this is an exponential function, so it's going to have the same shape as the other graphs. Again, this is just a sketch because it's a little hard to see. So there's 1/2 to the x. For 1/2 to the x plus 2, I can see that if it's 1/2 to the x, it's going to be all of these values, and plus 2 means I just need to add 2 to all of these values. So 2 plus 2 is 4, 2 plus 1 is 3, 2 plus 1/2 is 2 1/2, 2 plus 1/4 is 2 1/4. So these numbers, as x is getting bigger and bigger, the values for g of x are going to get closer and closer to 2. So I'm going to graph what I can. So I have the point -1, 4, 0, 3, and then my points are going to get really close to 2, but never cross y equals 2. So I'm going to draw this shooting up, and then this is going to get close to 2, but never cross it. So what transformation occurred that maps f of x to g of x? I can see that this was a shifting up of 2 units. Again, if this entire function was just shifted up 2 units, the previous function and the new function, or the image and the pre-image, are never going to intersect. For the end behavior, I can see it's the same for both of these functions. So as x approaches infinity, actually it's not the same. For f of x, as x is approaching infinity, y is approaching 0. And as x approaches -infinity, y is going to approach +infinity. But for g of x, as x approaches infinity, y approaches 2. So that asymptote shifted up 2 units as well. And then for x approaching -infinity, y is still going to approach +infinity. So here are 3 examples that we've seen so far of shifting exponential functions. So I can see that when I negate the x value, I'm going to reflect over the y-axis. When I negate the y value, I reflect over the x-axis. And if I add something outside the original function, that's going to be a shift up or down. So these are going to follow the same rules that you've seen often on shifting parent functions to whatever new function you may be looking at. In case we don't remember those rules, let's write them down. So if I have a number in front of the entire function, that's this a value, that's going to tell me that my parent function, or f of x equals b to the x, is going to be stretched or shrunk. So that's a stretch or a shrink. This h value, when I add or subtract inside the parentheses with an x, that's a left or right movement. So since this is negative, I know that this is getting moved right h units. When I add or subtract outside of the entire function, that's up and down. Since this is a positive, I know that this tells me to move up k units. If that was a negative, I'd be moving down k units. And if this was a positive, I'd be moving left h units. The negative in front of the a represents negating the entire function, negating y. So that's reflect over the x-axis. and a negative in front of the x value, so that's this negative here. If I am negating the x value, then that means I'm reflecting in the y-axis. Now, we're going to use these rules to write the equations of a function based on an original function and then some kind of transformation that needs to be done to it. So if I start with the equation y equals -3 to the x, and I want to do a translation of 2 -3 composed with a reflection over the y-axis, I always go from right to left when I perform these. I'm going to focus on this reflection in the y-axis first. So if I'm reflecting in the y-axis, that means I have to negate the x value. So that means in y equals -3 to the x, I'm going to have a negative in front of parentheses with the x. This transformation, when I see capital T and then 2 numbers, this first number tells you how much to move in the x direction, and the second number tells you how much to move in the y direction. So since I have a +2 here, I know I need to move right 2 units, which means I need to have a -2 in the parentheses. Since I want to move down 3 units, -3, I have a -3 on the outside. So there's my equation. Y equals -3 to the negative x minus 2 minus 3. Using these rules, you're going to do a couple of practice problems for writing the equation of an image. If you guys have any questions, feel free to leave them in the comments below. Have a great day.